Onwards to our second keynote for today, please welcome Mr. Hudi Zack, Chief Executive Director of the Technology Unit at the Israeli National Cyber Directorate. Since early 2018, Mr. Zack leads the Technology Unit and is in charge of all the R&D activities. He has over 30 years of experience in leading high-tech businesses and technology organizations, demonstrating both strategic and execution excellence. Mr. Zack, please.
Hi, everyone. I would first like to thank the organizers of this fascinating event for giving me the opportunity to speak in this important session. I will start off by quoting from a report submitted to the United States President by his National Security Advisory Committee. The quote says the following: "There is a small and rapidly closing window to ensure that IoT is adopted in a way that maximizes security and minimizes risk. If the country fails to do so, it will be coping with the consequences for generations." I think we can all concur with this statement, but the really alarming part of this report is the fact that it was submitted back in November 2014. So 6 years have passed since, the window of opportunity continues to close, and I can't say that we, as the leaders of the industry, managed to do much to change the way the market is evolving or improve the level of security in the IoT space, which by now includes over 20 billion connected devices and a very complex and comprehensive ecosystem which surrounds them and supports their activity. I think the Mirai botnet attack on the DNS provider on October 2016, which has shut down widespread services like Netflix and PayPal, was the point where the perils related to the IoT technology became evident to decision makers and executives in the public and private sector. Since then, we've witnessed many additional security events and new threats have emerged, targeting different aspects or components of the IoT ecosystem. All this is happening while IoT technology is gaining traction and is vastly used in a huge number of application and use cases, from home appliances, remote medicine, and all the way to factory automation and smart cities. Yet, as said, there's not been a breakthrough in how the different components of this technology are developed, manufactured, integrated, used, and even decommissioned. Thus, the inherent barriers to secure IoT-reliant world were left, by and large, unattended. When trying to set a security framework for the IoT ecosystem, we come across unique challenges related to the nature of this technology and how it is evolving. The fact that this industry is very fragmented with an enormous variety of products, standards, protocol, vendors, and use cases makes it difficult to set common measures that will be relevant for all the different players in the arena. The need to supply low-cost solutions and the necessary minimization of product footprint in terms of size, power consumption, and complexity is hampering the ability to introduce sophisticated security mechanisms that have been proven useful in higher-end IT environments. The nature of this technology, which is tightly connected to the physical world and impacts physical objects in real time, for example, in personal medical devices, requires a security framework to handle the threats also in real time, to avoid life-threatening or damage-inflicting consequences. Obviously, the sheer number of connected devices makes it hard to control and manage each and every component. And the fact that in many applications, these devices are installed in the field where they are not constantly supervised, but can be accessed by hostile entities, makes it even more difficult to maintain their integrity and avoid malicious interference. There are two more challenges that I would like to elaborate on. The first is liability. When we think of IoT, we usually think about the sensors and actuators in the edge, but the overall platform using these devices is much more complex and involves many players, each having an impact on the security of the overall outcome. These players include, among others, the manufacturers of the devices, the developers of the applications using them, the cloud supplier which hosts the back end of these applications, the implementers who integrate and install the systems in the field, and obviously the end users. If a security event occurs, it is unclear who, of all the entities I just mentioned, was responsible for preventing it, and is liable for any damage that may have been inflicted as a result of this breach. I believe legislators and regulators need to start defining some rules of engagement here, because as things stand, not any of the parties involved has the interest to try and fix the issues he has control of, and they all prefer to ignore the problem and expect someone else to do it instead. Think of vulnerability patching, for example. Who is in charge of ensuring the component software is up to date? Is it the manufacturer of the device, the software provider, the local integrator, the end user? As nobody is accountable for it, the common practice is that this vital process is simply not done. The devices remain out there with obsolete, vulnerable firmware and software, which makes them exposed to many types of attack on the availability and the integrity of the system operation. The second challenge I wanted to mention, which is not intuitively related to IoT, but in reality is tightly linked to many of its most important use cases, is the integrity of artificial intelligence systems using, managing, and controlling the IoT edge components. Since in many cases, IoT-based applications receive input from a huge number of sensors and need to make real-time decisions impacting a large number of components, for example, in a factory management system that is based on RFID tags, a human operator just can't be the one making the decisions, and most of the control is handed over to an IT-based algorithm. Now, this AI system is heavily reliant on the data it receives during the training and operational phases. And if a malicious actor is able, through control gained over some part of the IoT network, impact and poison this data, the AI algorithm will make the wrong decisions, creating overall system malfunction, where a human controller will only have limited ability to detect and overrule before it's too late. We need to start developing mechanisms to detect and block such malicious attempts, as they do not exist in most AI systems available today. Governments have a role trying to set committing frameworks for the different players, addressing the major gaps like the liability issue I already mentioned. But this activity's impact is limited due to the international nature of this market and the inability of a government, even if it controls a significant portion of the global market, for example, in the EU or the US, to supervise products and services supplied by countries beyond its jurisdiction. Therefore, a global coalition is needed to create a real shift in the market, where all the relevant vendors and countries take part in elevating the security standards of each and every part of this ecosystem. Sadly, in today's world, I don't see such a joint effort happening anytime soon. There is obviously value in defining frameworks and standards while trying to increase awareness and have more stakeholders working according to these guidelines. But these efforts will only have a limited effect, especially where the users are less educated and more cost-oriented, for example, in domestic applications. Trying to think of more direct approaches government can take to try to improve the IoT platform security within their borders. There may be more to be done beyond the obvious need to audit, guide, and ensure high security standards within the government systems and in critical infrastructure organizations whose OT environments are using IoT technology more and more every day. One can think of a government-managed platform that will scan the country's internet space and identify misconfigured or unpatched IoT devices. Then we can approach the owners, asking them to fix the problem, or, in case of an immediate and clear danger, intervene directly to make the necessary fix on the device, or even disconnect this device from the internet altogether. This seems like a bold move, and by itself raises liability as well as privacy issues. But in some cases, it may be the only way to avoid chaos resulting from a widespread attack. In Israel, we're in the process of launching a pilot, which we call the Lighthouse Project, of a similar concept for a different use case. This system is supervising and real-time fixing small, medium businesses' IT endpoints and routers in case of a pandemic attack. Expanding this concept to IoT devices will not be trivial and will definitely not solve the entire problem, but will be a significant step in the right direction and help avoid major damages in case of a sophisticated IoT-related large-scale attack. So, to summarize, IoT technology is developing and expanding, but the security gaps threatening its viability have stayed intact despite major efforts taken by many organizations and government over the last couple of years. There is a need for unconventional thinking and courageous steps to come up with creative ideas that will help overcome the inherent barriers for progress and enable us all to safely and securely leverage the vast range of possibilities IoT technology offers to improve the welfare of each and every one of us in the next decade and beyond. Thank you very much for your attention.